On the off chance that the red supergiant star Betelgeuse were to detonate right now, we would witness an exhibition of the 1,000 years. The sky would be ablaze, and the evening would be essentially as bright as day. Betelgeuse is going to detonate, that much is certain. However, researchers are not in complete agreement about whether it will be tomorrow or in 1,000 years. It's also possible that Betelgeuse has already detonated, and we haven't even seen it yet. A supernova blast happens in our galaxy about every 50 years. However, supernovae visible from Earth only occur once every few hundred years. Betelgeuse, which is around 640 light-years from Earth, will be a Type 2 supernova, and they are especially spectacular during the day. The blast of Betelgeuse would significantly alter the brilliance of the sky. Although the sun overwhelms the sky, the supernova would be bright enough to be visible even in sunlight. The brilliance would temporarily dazzle drivers and pilots, especially at dawn or dusk when the sun is lower, and the light from Betelgeuse hits people's eyes unexpectedly. This incredibly bright flare would only sparkle briefly. Then we would see a bright spot of light that would look like a new, very bright star. However, no sound would be perceptible as sound waves do not travel through the vacuum of space. At night, the blast would appear even more breathtaking. Briefly, everything would be illuminated, and then we would suddenly see a new, incredibly bright point in the night sky that would shine brighter than Venus and Neptune. This new source of light would probably be as bright as the full moon and could bathe the night scene in a brilliant light for a time. We would likely not see the stars near Betelgeuse due to the intense light from Betelgeuse eclipsing them. Noticing Betelgeuse, everybody is watching. While it's certain that Betelgeuse will detonate, it is still uncertain when it will happen. Astronomers around the world are keeping the star under constant observation, and even some satellites are focused on Betelgeuse nonstop. Every change, no matter how small, is recorded quickly. When the supernova alert goes off, astronomers and amateur stargazers will quickly point their telescopes at the event. Space telescopes such as the Hubble Space Telescope or the James Webb Space Telescope would take detailed pictures. The observatory's measuring instruments would record a massive increase in brightness across the globe, accompanied by an increase in gamma rays and X-rays. Radio telescopes would detect significant changes in the radio wave spectrum. On this extremely extraordinary day, gravitational wave sensors, which detect even the smallest changes in the universe, would likely register the blast even before we can see it. Gravitational waves are tiny changes in the gravitational fabric of the universe. All events in the universe where matter is moving produce gravitational waves. Additionally, abnormally high neutrino fluxes would likely be detected. The world's best neutrino detectors in the Arctic and Antarctic would likely also be among the first to register the event. What occurs later after the supernova blast? One thing is sure: Betelgeuse will scatter staggering amounts of matter and energy into space. The fragments of the star will spread across the galaxy over billions of kilometers and light-years. The impact wave from the blast will have a huge effect on Betelgeuse's immediate environment. However, the distances in the universe are so vast that it's uncertain whether neighboring stars will endure significant harm. Betelgeuse is the first red supergiant star to directly explode in our galaxy, and it will be the first time we can observe the display with modern technology. It will be astonishing to study the true size of the explosion for a long time. Shortly after the blast, Betelgeuse would remain visible as a very bright spot in the sky for weeks to months. Over time, the brightness would gradually decrease, meaning we will no longer be able to see it with the naked eye, although astronomers will continue to monitor any changes, however minor, with their telescopes. After Betelgeuse's explosion, a very small remnant will remain, either a neutron star or a black hole. Betelgeuse might even form a magnificent nebula such as the Crab Nebula, which would naturally be an extremely unique display. Such nebulae can exist for a long time, meaning that old stars don't disappear entirely but leave behind a remnant or black hole that provides us with a lot of material for research. The life of a star, what Betelgeuse used to look like. Do you also wonder what Betelgeuse's life as a star was like? We humans tend to be nostalgic and reflective, so let's reconstruct Betelgeuse's existence, and there are likely to be a few surprises. Around 10 million years ago, Betelgeuse was formed in a dense molecular cloud. This cloud of gas and dust consisted of materials traveling freely in the universe and also included remnants of earlier supernovae. Betelgeuse was thus formed from the material of older stars. At some point, this cloud became heavy enough that it began to collapse under its own gravity. A protostar initially formed within this cloud, which accumulated more mass until nuclear fusion began. Betelgeuse was not alone. The young star was formed in a massive nursery full of infant stars. This luminous and chaotic area might have resembled the present Orion cloud. The environment of the star nursery was characterized by strong winds and high UV radiation. Betelgeuse was an incredibly massive star from birth and was likely much brighter than its siblings. As a massive star, Betelgeuse had a shorter lifespan than smaller stars. From the start, it burned through its fuel supply relatively quickly. In its core, hydrogen atoms fused to form helium, and in the process, the massive star produced immense amounts of energy. This phase lasted a few million years, a blink of an eye in cosmic time. During this time, Betelgeuse was likely a blue supergiant and several times hotter and brighter than the Sun. In the middle of Betelgeuse's life, the hydrogen supply in the core was depleted, and the star began to fuse helium into carbon and oxygen. It was at this stage that Betelgeuse gradually started to expand into a red supergiant. Its brightness continued to increase, and it began to intermittently lose a lot of matter in the form of strong stellar winds. At this point, the red supergiant already had a diameter larger than the orbit of Mars around the Sun, and its radiant red color intrigued people on Earth. An interesting question is how planets around Betelgeuse could have experienced this development. Like us, Betelgeuse might have gathered a beautiful collection of planets around it. Some scientists consider it unlikely that life could have existed there, as we currently believe that life needs billions of years to develop, and given Betelgeuse's short lifespan, this seems rather improbable. However, we can never rule it out as we lack comparable conditions, and we would likely be making a significant mistake if we tried to transfer Earth-like conditions to other worlds. What is certain is that the planets around Betelgeuse became increasingly hot as the star evolved, and it gradually engulfed them. If there had ever been life there, it would have been destroyed by the star's extreme radiation alone. Supernova events. The extraordinary thing about supernova events like these is the incredible forces and timescales involved. The disturbances within Betelgeuse are so immense that we can barely grasp them with our minds. When Betelgeuse had burned through the helium in its core, it began to fuse heavier elements: carbon, neon, oxygen, and finally silicon, which combined to form iron. This process accelerated, and at each fusion stage, less energy was produced as heavier elements accumulated. Betelgeuse became heavier and eventually would collapse under its own gravity. Then it will tear the massive star apart in a fraction of a second. The remaining energy will be released suddenly. How close is Betelgeuse to exploding? When will it detonate? The question on everyone's mind is, when will it happen? And will we see it? Betelgeuse is increasingly unstable, as all observations show. It is certainly in its final stage, but how long this will last is a mystery. Astronomers are using various telescopes and technologies to monitor Betelgeuse closely. In addition to the Hubble Space Telescope and the James Webb Space Telescope, the European Southern Observatory's Very Large Telescope and the ALMA telescope in the Atacama Desert are also observing the star. These telescopes' observations show us compositional changes and variations in its brightness. Between the end of 2019 and the beginning of 2020, the star's brightness decreased by about 25%, which attracted worldwide attention and sparked speculation about the imminent supernova. However, after detailed investigations, space experts concluded that the dimming was likely caused by a combination of various factors. A massive dust storm expelled from the star and large-scale convection cells on the star's surface, which were cooler than the rest of the star, darkened the star for months. Researchers also observed another, though less dramatic, dimming of Betelgeuse in 2024. This event is thought to be a direct consequence of the 2020 obscuration. Although these phenomena can be explained, they show us how unstable the star is and can be taken as significant indications that Betelgeuse may soon detonate or has already detonated. The astonishing thing is that the star could have gone supernova some time ago, even many years ago, but we won't see its light until 650 years from now. What will change? Many people regularly gaze at the Orion constellation. As we contemplate the eventual detonation of Betelgeuse, It's essential to understand the broader cosmic context and the implications for both astronomy and our understanding of stellar evolution. Betelgeuse's impending supernova is not just a significant event due to its immediate visual impact, but also for the wealth of scientific information it will provide. The explosion will offer a unique opportunity to study the life cycle of massive stars in unprecedented detail. Supernovae are crucial to the cosmos because they serve as the primary mechanism for dispersing elements throughout the universe. These explosions forge and scatter elements heavier than iron, such as nickel, cobalt, and various rare elements, into space. These materials eventually become part of the interstellar medium, contributing to the formation of new stars and planetary systems. Thus, Betelgeuse's supernova will act as a stellar recycling event, enriching the surrounding regions with a fresh supply of heavy elements, which are essential for the development of planets and possibly life. In addition to enriching the interstellar medium, the shock waves from the explosion can trigger the formation of new stars. The intense pressure from the supernova can compress nearby gas clouds, leading to the collapse of these clouds and the formation of new stellar objects. This chain reaction is known as triggered star formation, and it has been observed in the aftermath of previous supernovae. Consequently, Betelgeuse's explosion might not only illuminate our night sky but also set off a new generation of star formation. The study of Betelgeuse's supernova will also provide insights into the physics of supernova explosions themselves. Despite extensive research, the exact mechanisms behind supernovae are not fully understood. Observations of Betelgeuse will help refine models of these colossal explosions. For instance, how exactly the core collapse leads to the ejection of outer layers, and the nature of the neutron star or black hole that forms afterward, are areas still under investigation. Observations from different wavelengths, including visible light, X-rays, and radio waves, will be crucial in piecing together the puzzle. Moreover, the explosion will provide a natural laboratory for studying the behavior of matter under extreme conditions. The core collapse supernova process involves temperatures and pressures that are not replicable on Earth. By analyzing the remnants of the explosion and the light curves, the brightness of the supernova over time, scientists can gain insights into the state of matter in these extreme environments. This can improve our understanding of fundamental physics, including the behavior of nuclear matter, relativistic effects, and the role of neutrinos in stellar explosions. The role of neutrinos in supernovae is particularly intriguing. Neutrinos are elementary particles that interact very weakly with matter, making them extremely challenging to detect. However, during a supernova, an enormous amount of neutrinos is produced. These particles carry away a significant fraction of the supernova's energy, and their detection can provide crucial information about the dynamics of the explosion and the properties of the collapsing star. The study of neutrinos from Betelgeuse's supernova will be a valuable addition to our knowledge of these elusive particles. On a more practical note, the visibility of the supernova from Earth will be a spectacular event. The intense light from the explosion will make Betelgeuse one of the brightest objects in the sky, potentially visible even during daylight. This visibility will make it a focal point for amateur and professional astronomers alike, providing an excellent opportunity for public engagement with science. The event will likely inspire a new generation of astronomers and space enthusiasts, much like previous supernovae have done. For the general public, the spectacle of a nearby supernova will offer a rare glimpse into the dynamic and ever-changing nature of our universe. It will serve as a powerful reminder of the forces shaping the cosmos and the ongoing processes that govern stellar life cycles. The visibility of the explosion and the subsequent observation of the remnants will engage a wide audience, from school children to seasoned astronomers. The study of Betelgeuse will also enhance our understanding of the life cycles of red supergiant stars. These stars are among the most massive and luminous objects in the universe, and their evolution provides key insights into the fate of such stellar giants. By examining Betelgeuse before and after its explosion, scientists can refine models of stellar evolution and supernova mechanisms. Furthermore, the data gathered from Betelgeuse's supernova will contribute to our knowledge of cosmic distances and the rate of expansion of the universe. Supernovae are used as standard candles to measure astronomical distances, and the detailed observations of Betelgeuse will help calibrate these measurements. This can refine our understanding of the rate at which the universe is expanding, providing insights into the fundamental nature of dark energy and the overall dynamics of cosmic expansion. In summary, the anticipated supernova of Betelgeuse holds significant scientific and public interest. Its explosion will provide a wealth of information about stellar evolution, element formation, and the physics of extreme environments. As we await this celestial event, the observations and data gathered will not only enrich our understanding of the universe but also captivate our imagination, highlighting the awe-inspiring processes that shape the cosmos.